Okay, today we're taking on midpoint and distance formula, more, and quiz 1 review. So first up, I'm having you review how to simplify a radical. So when I look at the square root of 250, I'm looking for pairs that multiply to 250. So one pair that I can think of would be 25 and 10. So the reason I like that pair is because 25 is a perfect square. It's made up of 5 times itself, 5 times 5. So it's going to give me a pair of 5s. I'm always looking for pairs of the same thing underneath the radical, underneath the square root. Okay, for 10, I can't think of any two of the same numbers that would multiply to go into 10. So I'm going to leave the 10 as is. So when I write my answer on the outside, for every pair that we see underneath the radical, we pull them both out and we leave one on the outside to represent the pair that was underneath. So underneath the radical is the 10. So this reads as 5 square root 10, or 5 times the square root of 10. One way that I can check, if I look at the 5, if I square the 5, so 5 squared is 25, and then multiply that back by the 10, that would take me back to the original structure, the square root of 250. So there's always ways to double check to make sure that you're doing something correctly. All right, the next one reads as -5 times the square root of 96. So whatever I'm able to pull out, it has to multiply by the -5 that's already on the outside. So when I look at 96, I'm looking for the biggest perfect square that goes into 96. And I can see 16 times 6. And 16 will give me a pair of 4s. There's no pair that goes into 6 that's going to give me the same number. So I'm just going to circle it because it's a dead end. So on the outside, I have a -5 times 4. And underneath my square root, I have a 6. So if I multiply this back, -5 times 4 gets me -20 times the square root of 6. And that's my final answer. Okay, next up, here I'm saying the endpoints of segment AT are given. Plot the endpoints and draw the segment on the coordinate plane. Then find the midpoint and the length. Leave the length in simplified radical form. Okay, so I'm going to need a straight edge here as well because I want to connect my dots. So A is -2, 1, so -2, 1 right here. And B is 2, -7 right here. Okay, I'm going to connect my dots. So here to here. And I'm going to label my endpoints. Here is A, and here is T. All right, so when I do the midpoint, I'll do that first. So midpoint. Midpoint is always the average of the x's and then the average of the y's. So to get an average, that means I'm adding the two x values, dividing by 2. I'm adding the two y values and dividing by 2. Okay, and then, like I said, in just language, we're saying it is the average of the x values and average of y. Okay, so then when I plug in, I'm looking at the x values, so -2 plus 2 divided by 2. For the y's, I have 1 plus -7 divided by 2. Okay, so here, a -2 times, or -2 plus 2 gets me 0, so 0 over 2. And then over here, I get -6 over 2. So 0 over 2 is 0. -6 over 2 is -3. So right there, that's my midpoint, 0, -3. I go back and I look at my graph, I want to make sure that that makes sense. So 0, -3, that would be right there. That makes perfect sense, right? That is the midpoint, the middle point. It's the place where it bisects the segment and creates two congruent parts, right there. Okay, next we want to find the length or the distance between 2 points. So for length, we're using the distance formula. And the distance formula, as I showed you in the previous day's lecture, is really just looking at Pythagorean theorem on the coordinate plane. So I'm looking at a big square root, difference between the x values, squared, plus difference between the y values, squared. Okay, but the order we pull it, it really doesn't matter. So I could also write the formula as x2 minus x1 squared plus y2 minus y1 squared. Again, we're all under the big square root. So now if I use my distance formula and I use these coordinates up here, let's say that I plug into the first one. It doesn't matter. I'm going to say that a couple of times. It doesn't matter. So here I could plug in -2 minus 2 squared plus 1 minus -7 squared. Okay, we should know that when we subtract a negative, it goes to a positive, so this is a plus right here. Next stage, here I have a -4 squared, and here I have 8 squared. Next stage. So -4 squared is 16, 8 squared is 64. So I end up with the square root of 80. So if I simplify the square root of 80, that breaks into 16 times 5. 16 will give me a pair of 4s, right? It's a perfect square with that 5 staying behind. So my answer will be 4 square root 5. Okay, I want to point out one other little shortcut, which you have seen me do in class. So it's just one other way to get to that same end result. Okay, just a little bit faster if you can visualize the right triangle. Okay, so here if I can visualize that right triangle, let me sketch it out like so. So I'm picturing AT as the hypotenuse of my right triangle. So it's if I was drawing in that vertical segment and that horizontal segment right here. So that's what I have right here, my little red right triangle. So the horizontal distance between, so if I'm looking here again at that right triangle, that horizontal distance between those 2 points really is 4 units. And the vertical distance between those points, right, that would be 8 units. So my shortcut is really using the Pythagorean theorem, just solving for the hypotenuse, the C. So C is equal to square root of a squared plus b squared. Okay, and then we're just plugging into that. So C is equal to the square root of 4 squared plus 8 squared. So the 2 legs, 4 and 8 are the 2 legs. So now I have the square root of 16 plus 64. You can see the same exact numbers that we saw up here, which then gets me, of course, the square root of 80, and then we're back to 4 root 5. So we can really bypass the formality of the distance formula if we can recognize that we're solving for the hypotenuse of a right triangle. We just need to note what is the horizontal distance between the points, what is the vertical distance between the points, and we're really just using Pythagorean theorem. Let me slide this up. All right, next, example 3. The midpoint and one endpoint of segment CD are given. Plot the endpoint and midpoint and draw the resulting segment on the coordinate plane. Then find the coordinates of the other endpoint. Okay, so let's start by plotting those 2 points. So we have -7, 5. So right there will be point C. And then m is at -3, -1. So right here would be m. Okay, I'm going to connect those dots. And what I want to make sure that we're super clear on is that m, right here, that's our midpoint. So here in this problem, we are given one endpoint, we're given the midpoint, and we're trying to find the other endpoint. So there's really two ways we could do it. So we could visualize that segment. I'm going to try that strategy first, where I know what C is, I know what M is, and I'm trying to figure out what endpoint D is. I know that C is -7, 5. I know that M is -3, -1. Again, that is the midpoint. D is the other endpoint. So M is where it bisects this segment and creates two congruent parts. So D is what I want. That's what I'm seeking. So I'll make a little box right there. So if I focus on the x values, so here and here, if I know that -3 is the average of two numbers, that means that it's right smack in the middle of this number and this number. It's equidistant to those two extremes. So if I'm looking here to here, I can see that, well, we subtracted 4 from -3 to get to -7, which means over here we must have to add 4, right? That's the nature of an average of two numbers. It's right smack in the middle. So that tells me that the x value has to be 1. I just don't know the y value yet, so I'm just leaving a little space for it. So now if I look at the y values, let me underline those in purple, I can see that to get from -1 to +5, we've really added 6 units. So to get to the other y value, I would have to take away 6 units. So 1 minus 6 is -7. So again, that didn't get me the x value, so I'm leaving a little gap here. It gave me the y value at -7. So when I put these two values together, D is at 1, -7. All right, so that's just playing off the idea of what makes something an average. An average is right smack in the middle of two other extremes. So if I said, what's the average of 10 and 20? We know that's 15. 15 is 5 more than 10 and 5 less than 20, right? It's 5 units away from both of those extremes. Okay, let me show you another pathway. So here I could take a more algebraic approach. So let's say that I want to find x. So I know that -7 plus my unknown other x value, I know that when I divide it by 2, so -7 plus that unknown x value divided by 2 will get me the x value of my midpoint, -3. So now if I want to solve for x, I'm going to clear my fraction by multiplying each side by 2. So now I have -7 plus x equals -6. I add 7 over, and x equals 1. All right, so it just confirms it, right? I knew that it was 1, right, with my other approach. Okay, I want to find y. Okay, so I know then that 5 plus my unknown y value divided by 2 will get me to -1. So again, I'm going to clear my fraction by multiplying each side by 2. So now I have 5 plus y equals -2. Okay, take away the 5, and y equals -7. Okay, so again, it's really just confirming for me the same answer that I got over here. So my answer here is, again, 1, -7. So let's plot that just to visualize it. 1, -7 puts me right here. So if I draw that in, just like so, I can see that this must be point D at 1, -7. Right? When I look back at the midpoint, when I look back at M, I can see that it's right smack in the middle. Okay, I just want to remind you that a midpoint bisects a segment. Okay, when we bisect a segment, it creates two congruent parts. So I'm going to write here dividing it into two congruent parts. So I could write a congruent statement that segment CM is congruent to segment MD. Right? They are congruent, they match perfectly. I could even put a little tick mark here and here to show that in my diagram. All right, let's go to that next page. All right, so for this second page, I'm saying classify each polygon by the number of sides. So here, I'm looking at 1, 2, 3, 4, 5, 6, 7 sides. And I'm also asked to state whether it is convex or concave. So if it is convex, that means that each of these interior angles has to be less than 180. If it's concave, that means that we have an interior angle that is in excess of 180. So here, they all look like they're less than 180. So this one is a heptagon because of the 7 sides. So 7 sides is a heptagon, and it is convex. Okay, over here in B, let me count them. 1, 2, 3, 4, 5, 6. We have 6 sides. Okay, 6 sides means it's a hexagon. And then here I see that this angle, right, a really big angle, it is in excess of 180. I can see that there is a cave built into it. Let me remind you of that. So concave, there's a cave built into it. This is an example of concave. So this is a hexagon, right, because of the 6 sides, and it's also concave. All right, next example. City E, let me slide that up a little bit. City E is on a straight stretch of highway between city D and city F. The distance from city D to city F is 72 miles. The distance from city D to city E is 2 more than 6 times the distance from city E to city F. Find each distance. Okay, so first off, I'm just going to make myself a picture, right? That helps anchor myself into the problem. So I need a straight stretch of highway, right? So I'm just going to draw a straight pathway. And I don't know quite how far they are apart, but I know that E is in between D and F, so I'm just going to draw it like this. D, E, and F. Okay, clearly not to scale, because again, I don't know how far E is from D or from F. So let me read back through the problem. I know that the distance from D to F is 72 miles. So I know that this whole span is 72 miles. We're also told that the distance from D to E, so that's this distance right here, is 2 more than 6 times the distance from E to F. Well, this is E to F right here. So we're defining the distance right here in terms of this distance right here. So E to F, that is my X. That's my unknown. So then if I read back 2 more than 6 times the distance from city E to F? Well, this would be 6x plus 2. Okay, so I can see that these two smaller parts are defined as 6x plus 2. This one is x. This full span is 72. I know that the smaller parts add up to the larger whole. So I know that 6x plus 2 plus x will equal 72. Okay, next, I need to consolidate the like terms. So 6x plus x is 7x, and then plus 2 equals 72. Take away the 2, 7x equals 70. Divide by 7, and x equals 10. All right, so x equals 10, and I've defined that as e to f. So e to f is 10 miles. Okay, and then dE is 6 times 10, 60, plus 2 would be 62 miles. Okay, if I just double check, do these two numbers add back up to that whole, that total of 72? They absolutely do. I'm always checking along the way to make sure that they add up to that whole distance 72. All right, next up. So example 6. So here we're given a diagram. We know what tick marks mean. Tick marks mean congruent. So that means that this segment is congruent to this one. And then these double tick marks, these two segments here, they're congruent too. So let me label what I'm told. Again, not to scale. So FR, so this whole span is 74. I like to make words, so this one is flower, in case you couldn't tell. So the whole was 74. Okay, I know that LO is 15. So from here to here, that's 15. Which means that from here to here, also 15, right? Because those segments are congruent, so their measures must be equal. Okay, I know also that OW, so here's OW, is 9 less than 2 times ER. Let me write that as a statement. OW, so let's build an equation from that statement. OW will be 2 times the measure of ER minus 9. So OW, this measure, 9 less than 2 times this measure right here. Ultimately, we want the length of FL. Okay, so now I could write this as OW, I know that's 15. So 15 equals 2 times, well, I need to figure out what x is, so I'll call it ER is x. I'm just defining ER as x right now, and then take away 9. So I've built myself an equation where 15 equals 2x, take away 9. So now if I solve for x, and add the 9 to each side, so 24 equals 2x, divide each side by 2, I'm getting that x is 12. So right here then, that must be 12. And since these two segments are congruent, this must be 12 also. So now, I'm just trying to get to what FL is, right? That's what I'm asked to solve for. What is the length of FL? Well, FL must be the leftover. So FL must be, I'm going to take that 74, take away the 2 15s, and the 2 12s. So if I take 74 and I deduct 15, 15, 12, and 12, I'm left with 20. So FL equals 20. Okay, one more problem. So in example 7, we have points B and T, and they're placed on line G on opposite sides of point A, so that the measure of BA is 5 times as long as the measure of TA. So 5 times as long as what TA's measure is. What will be the value of TB to AB? Okay, so let's, again, make a picture. So B and T are on opposite sides of A. So let's put A here, and I'll put B here, and T here. So again, I'm not doing this to scale, right? I'm just giving myself a visual anchor. Okay, next. So go back and read it. BT, that measure, is 5 times as long as this measure right here. So since we're defining BA in terms of TA, I'm going to call that X. So here to here, that is X. BA is 5 times X. Okay, then the whole thing would be 6X. So if I want to use X, I can do that, but I actually could also just plug something in. So another option, I could say, well, what if TA is a unit of 1? Let's try that. Let me mark that in green. So if that's a unit of 1, and then BA is 5 times as long as TA, right, then that would be 5 times 1. Well, then that's just 5. And then this whole span would be 6. So if I do it the first way, here, if I'm finding the ratio of TB to AB, TB here to here has a measure of 6X, AB has a measure of 5X. Well, whenever I have something over itself, that reduces to 1, like that. So that's going to give me a 6 to 5 ratio. Okay, if I did it this way, I can bypass reducing those X's. I can see that from B to T, or T to B, that is 6. AB, that is 5. So I'm just getting there a little bit faster if I do it the second way. Both options work. So the ratio of TB to AB, the measure of segment TB, the measure of segment AB, is going to be a 6 to 5 ratio. Just like that. All right, that's all I have for today. Have a good rest of your day.